Okay, so here's page 1 of the study guide. So question 1 says which must be a regular convex polygon. Well, first I'll eliminate some. A is not a polygon because it has curved lines. A polygon can only have segments. The other three are polygons. Convex, though, C is not convex, so I'm going to cross out that. That is concave because remember, if you draw a diagonal from this vertex to this vertex, it goes outside of the polygon. So that makes this one concave. So these two, B and D, these are both polygons and they're both convex, but regular means they have to have, all sides have to be congruent and all angles have to be congruent. So that would be D, because this one is not regular because this side has 2 notches and this side has 1. So those are not all congruent. So the answer is D. Number 2, which is an irregular concave polygon. So again, I'll eliminate some. So again, this is not a polygon. Concave, well, this is not concave, G, because if I connect the diagonals, all the diagonals are inside of the polygon. Same thing with J. J is concave. J is convex. So this is not one, this is not one. And so H is a concave polygon, and the reason that it's irregular is because not all of the sides are congruent. This side is not congruent to this side, and this angle is not congruent to this angle. So that automatically makes it irregular. Number 3, what is the formula for the sum of the interior angles of a polygon? So if you want to add up all the interior angles, what will it equal? Remember, you take n minus 2 and you multiply that by 180, and n is equal to the number of sides. Number 4 says what is the sum of the exterior angles of a polygon? So the angles on the outside, and that's always 360 degrees, no matter how many sides it has. 5, 6, and 7, tell whether each figure is a polygon. If it is a polygon, name it by the number of sides. Number 5 is not a polygon because it is not a closed figure. You would have to close this line to make it a polygon. Number 6 is a polygon, and it has 3 sides, so that makes it a triangle. And number 7 is a polygon because it's made of segments, it's closed figure. And let's count the number of sides. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 sides is a dodecagon. So remember, you have that chart where it lists the number of sides, and then you have to name it. So 3 sides is a triangle, 4 sides is quadrilateral, 5 sides pentagon, 6 sides hexagon, 7 sides heptagon, 8 sides octagon, 9 nonagon, 10 decagon, and 12 dodecagon. And then if it has more than 12 sides, you just call it an n-gon. So 15 sides would be a 15-gon, 20 sides would be a 20-gon. So 8, 9, and 10 tell whether it's regular or irregular. So remember, regular means all of the angles are congruent and all of the sides are congruent. And irregular means all the sides are not congruent or all the angles are not congruent. And then tell whether it's concave or convex. So concave, remember, means that if you draw a diagonal, it is outside of the polygon. And convex means if you draw all the diagonals, they're all inside of the polygon. So number 8, this is irregular and it is concave. The reason that it's irregular is because all of these sides are congruent because they all have little tick marks in them, and all of these angles are congruent, but they don't say anything about these angles. I mean, this is an angle right here too, and this is an angle, and they don't say anything about those, so we don't know if all of these angles are congruent, so that would make it irregular. And the reason that it's concave is because if I drew a diagonal from this vertex, and remember, you connect this to a non-consecutive. So I connect it to this vertex, I connect it to this vertex, I connect it to this one, right? And if I drew every single vertex, every single diagonal, some of those diagonals go outside of the polygon. Or if I picked this one and drew all of my diagonals. Again, some of the diagonals would go outside of the polygon, and that makes it concave. So number 9, this is irregular because not all of the sides are congruent, but it is convex because if I drew all my diagonals, they're all inside. But again, irregular because the side is not congruent to the side. Number 11, this is regular because all of the angles are congruent and all of the sides are congruent. And this is also convex because if I drew every single diagonal, which I mean there's a lot of them, but if I drew every single diagonal, all of the diagonals would be inside of the polygon. So I could keep going. All right, number 11, find the sum of the interior angle measures of a convex dodecagon, which is 12 sides. So I'm going to do 12 minus 2 times 180. So that would be 10 times 180 degrees, which would be 1,800 degrees. Oops. All right, so that's the sum of the interior angles. Number 12, what is the sum? So again, sum, I'm going to take all of the interior angle measures of a convex hexagon, which is 6 sides. So I'm going to do 6 minus 2 times 180. So that's 4 times 180. So 4 times 180 is 720 degrees. All right, so next one. What is the sum of the interior angle measures of a convex 33gon? So 33 sides, so n is 33 minus 2 times 180 degrees. So 33 minus 2 is 31, sorry, times 180. And then 31 times 180 is equal to 5,580 degrees. Number 14 says, what is the measure of each exterior angle of a regular pentagon? So again, each exterior angle, so I don't want the sum, I want each one. Exterior angles, if you have a convex polygon, the sum of the exteriors is always 360 degrees. It's a regular pentagon. Pentagon means it has 5 sides, and regular means all of the angles are the same. So I mean, if I drew this, and let's pretend this is regular, that every side is congruent and that every angle is congruent, right? If I'm looking at the exterior angles, so if I, extend this side and then I'm looking at this angle right here, and then if I draw another one, all of these exterior angles are going to be congruent. Because remember, there's 180 degrees in this straight line, but if this, whatever this angle is, it's congruent to this one, so those other angles that make them supplementary are going to be the same. So if I add all of these exterior angles together, it's going to equal 360 degrees, but I'm going to divide it by those 5 exterior angles because it's a pentagon. So if I take 560 divided by 5, that's going to give me 72 degrees. So each of these angles is going to be 72 degrees, and then I could keep going, and all of these exterior angles would be 72 degrees. Number 15, what is the measure of each exterior angle of a regular octagon? So same type of problem, because all of this, the sum of the exterior angles would be 360, but because I want the measure of each angle, I'm going to take the 360 degrees if I add up all the exterior angles, and I'm going to divide by 8 sides. So if I take 360 and divide that by 8, each exterior angle is 45 degrees. And the measure of each exterior angle of a regular 18gon, so I'm going to take 360, which is the sum of all the exterior angles, divided by 18, because it's a regular 18gon, so all of those angles are going to be the same, and that's going to give me 2 degrees. All right, is that it? Yep, that's it for page 1.